Hello viewers, my name is Mr. Adebanjo and I want to welcome you to this video. In this video, we are going to be discussing sine and cosine rules. We are going to be discussing sine and cosine rules in this video. And there is a reason why we are going to be discussing this sine rule and cosine rules. Because in the next video, we are going to be discussing bearing and distance. Bearing and distance. And there's no way you can understand bearing and distance, or there's no way you can resolve question on bearing and distance if you don't know sine rule and cosine rules. Because some of the question, when you interpret some of the question, you're going to be getting some triangle that are not right angle triangle. So in that case, you will need sine rule and cosine rule to deal with them. So we are going to be dealing with the sine rule and cosine rule, and we are going to understand it better and how to apply cosine and sine rule to solving triangles. Excuse me. So without wasting much of our time, what are we going to be doing in this video under these topics, sine rule and cosine rule? We are going to be telling you the reason why we need to know sine rule and cosine rule, although I've already told you one of the reasons, because you will need them under to solve bearing and distance, and that's one of the reasons why we need sine rule and cosine rule. So that's the reason I'm going to tell you in this video. So I'm going to tell you how what sine rule is all about, and the condition that a triangle must satisfy before we can use sine rule. We are going to be telling you as well. We are going to be telling you the application of how to apply sine rule to solving triangles, and also we are going to be telling you what cosine rule is all about, and how we can also apply cosine rule to solving triangles as well. Then we are going to be applying these two rules to solving a past examination questions, whether WAHEC, NECO, and JAMS. And I must tell you all the questions we are going to be resolving under this video, or in this video rather, past questions, whether objective question or theoretical questions. So I want you to sit back and enjoy this wonderful video on sine rule and cosine rule. But before we get it started, please, if you are yet to subscribe to this channel, please, there is the only way you can help us to improve this channel is by subscribing to this channel. Please click on the subscribe button right now on the channel, and you can click the bell button as well, so that you'll be notified whenever we post information on this platform. Please share this video with a student out there so that they will benefit from it. Like the video, comment in the comment section of this video so that help us improve on our next video. So without wasting much of our time, please let's dive straight into the learning of sine and cosine rules. So before we tell you what sine and cosine rule is all about, let's first of all know the reason why we need to understand sine rule and cosine rule. Why do we need to understand sine rule and cosine rule? There are quite reasons, or there are a number of reasons why we need to know sine rule and cosine rule. One of them I've already told you, that in solving bearing and distance, we are going to be solving this in the next video. You must understand what sine rule and cosine rule is all about, because when you interpret question on bearing and distance, you're going to get triangle, and some of the triangles are not a right angle triangle. So to resolve the angles and the side of that triangle, you need to understand sine rule and cosine rules. So another reason is that to solve a triangle, it means that we need to find the values of unknown side and angles. So if question asks to resolve a particular triangle, that means they want you to find all the sides and all the angles in that triangle. And if the triangle is a right angle triangle, we know the principle you are going to apply in solving the triangle. In the previous videos that we have discussed on trigonometric ratio. We have also discussed on Pythagoras theorem. So those videos are there to enlighten you, and we can only apply trigonometric ratio and Pythagoras theorem to right angle triangle. So if you want to resolve the angle and the side of a right angle triangle, the only principle we can apply are either trigonometric ratio and or what and Pythagoras theorem. So it means that those two theorems or those two principles can only are only applicable to right angle triangle. So what happened to remaining triangles that we have? How do we resolve their angles? How do we resolve their sides? All the triangles that are not right angle triangle, how do we find their sides? How do we resolve their angles? There have to be a principle to deal with them, and that is where sine rule and cosine rule comes in. That is, if you have a non-right angle triangle, trigonometric ratio and Pythagoras theorem cannot be applied to them. Yes, it means you cannot apply trigonometric ratio and Pythagoras theorem to a triangle that is not a right angle triangle. So the rules that are applicable to those triangles are sine rule and cosine rule. So you use sine rule and cosine rule to resolve the sides and the angles of a non-right angle triangle. Am I communicating at all? So that's one another reason why we need to understand sine rule and cosine rule. So if you are given a triangle that is not a right angle triangle to solve, that means your mind should not be going to trigonometric ratio. Your mind should not be going to Pythagoras theorem because it is a non-right angle triangle. Those two principles are only applicable to right angle triangle. So if you are given a non-right angle triangle to resolve, that means the only thing that should come to your mind is sine rule or cosine rule. Hope I'm clear. Good. So then let's discuss sine rule. Let's discuss sine rule. What's sine rule saying and how can we apply it? Assuming I have a triangle like this on the screen right now, look at this triangle, and we can see that this triangle is not a right angle triangle. Why? Or this angle here is an acute angle because it's less than 90. It's also an acute angle, another acute angle. So none of these angles here are right. Is right. None of the angle here is a right angle. Is a right angle. So this triangle is not a right angle triangle. But assuming we are given this triangle, um, this angle here is angle A, and this angle here is angle B, and this angle here is angle C, and we can see the angle here is angle B. That means the side that is facing this angle B, we can use a small letter B to represent that side. So if this angle here is angle B, that means the side facing it will carry small letter what B. So if this angle here is angle A, that means this side that is facing this angle here will carry what small letter A. And this angle here is angle C. That means this side facing it will carry what small letter C. Do you understand what they are trying to say now? So if I label this angle here to be angle P, then this side will be carrying a small letter P. If I could label this angle Q, the side facing it will be will carry small letter Q. And if I label this angle here as angle R, this side will carry small letter what? R. Are we there? Then what is sine rule saying? Sine rule is saying that the ratio of the side, which is side A here, to the angle facing it, which is sine, so to the sine of angle facing it, which is sine A, is equals to the ratio of the side B to the sine of the angle facing it, which is angle B, is equals to the ratio of side C to the angle facing what? Sine C, which is sine what? Sine C. That is to say that A, which is talking about this side, over sine of the angle facing it, which is sine A, is equals to B, which is talking about side now, over sine of the angle facing side B, which is angle B, equals to C, which is side, over the angle of the side facing the side C is what? Sine of angle what? C. So technically, if I have this angle here to be Q, that will be having here small letter Q here. That means I'll be having small letter Q over the angle facing, which is sine of angle Q. If I call this place P, then I'll be this place will be small letter P. That means I'll be P over sine of what? Angle P. If I call this one angle R, then I'll be having this place will be R. So we'll be having R over sine of what? Angle R as well. So this is the what sine rule is saying and what sine rule is talking about. So the side over the sine of the angle facing the side equals to the side another side over the sine of the angle facing that side equals to the third side over the angle facing the side as well. But the first thing we need to know is that we cannot use all these three of them at the same time. No, we can only use two at the same time. We cannot use the three of them at the same time. We can only use two at the same time. We cannot use three, depending on the question given to us. And you're going to be seeing how we are going to apply it soonest. So there is a condition that a triangle must satisfy before we can use sine rule. A condition must be satisfied before we can use a sine rule. What is the condition? An angle and opposite side must be given, and I call that one a pair. That is to say, if before I can use sine rule to resolve a triangle, having known that that triangle is not a right angle triangle, then what condition must be satisfied before I can use sine rule? A pair must be given completely. What do I mean by a pair? An angle and the side facing the angle must be given. For example, let's say, what do you mean by this pair? Let's say I must be giving this angle with the side facing it. That's a pair. This angle and the side facing it, that's a pair. So if I'm giving this angle and the side facing it, that's a pair. Then the other pair is given halfway. So if I'm giving this pair full, then the other pair I'm using against it must be given halfway. Assuming I'm giving this angle now, looking for this side facing, that's a halfway now. Or I'm giving this side, looking for the angle facing it, that's a pair, half pair. The other pair is given halfway now. So to use a sine rule, a pair must be given completely. An angle and opposite side must be given. I must be assuming I'm giving this angle now, and I'm giving this side. That's a pair now. Then the other pair I'm looking for will be given halfway. Is it that I'm giving the side facing it, looking for the angle, or I'm giving the angle looking for the side. I may be giving this pair as well. I may be giving this angle with the side facing it. That's a pair now, to look for the second pair that is given halfway. So a pair must be given halfway. So a pair must be given, then the second pair is given halfway to be able to use sine rule. Let's try out some triangle to see whether you understand what the condition that must be satisfied before we can use a sine rule. Let's say I'm giving this triangle now. Look at this triangle. We are giving this angle as 45 degrees. This angle is 60 degrees. You have this side to be given 6 meters, and we have to look for this side, which is B. The question is, can we use sine rule to find this value of B? Can we use the sine rule to resolve this triangle? Is the condition for sine rule satisfied? I'm out to answer that question. Is the condition for using sine rule satisfied here? Let's go back to condition. Condition say that a pair must be given. That is, an angle and opposite side must be given. That's a pair. Let's go back. So now look at this angle, 60 degrees. Where is the side of that angle? This is the side. Sorry, where is the side facing this angle rather? This is the side facing it, and it is given to us 6 meters. So that means this angle and the side facing is given. So that means this is a pair, and it's given. Now look at this angle now given to us 45 degree, and where is the side facing in? This is the side facing. That's the side we are looking for. So that means this one is given halfway now. So this is a pair given completely, and this pair is given what? Halfway. That means we can use sine rule in this case. So that means the condition for sine rule is satisfied. An angle and the side facing is given completely. That's a pair. Then the second pair This angle is given, but the side is not given. So you can use sine rule in this case. That's the second pair is given halfway. Let's see another triangle. Look at this triangle now. We are given this angle, and the side facing it is not given. We call it y. And you are this side also is labeled x. Is not given. So this angle is not given. This angle is not given. The question is, can we use sine rule in this case to find either y or x? I answer the question. Can we use sine rule in this case? The answer is no, because no pair is given completely here. This angle is given, the side facing is not given. Then this side is not given, this angle is not given, this angle is not given. So we cannot use sine rule to resolve this kind of triangle. Are we clear? Good. Let's see another one. Look at this triangle on the screen right now. Look at it critically. Can we apply sine rule to resolve this triangle or to find the value of x here? Can we use sine rule? No, not yet. But something can be done. Okay, not yet. The reason being that this angle is given, this angle is given, then this side is not given. You're looking for this side, and this side is given to us. So that you can see now there's no pair that is given completely. Look at this angle is given. The side is not. The side opposite is not given. This angle is given. The side is opposite is not given. This side is given, but this angle is not given. So right now we cannot apply sine rule here. But there's a way we can find this angle here so that we now have a pair completely. Because this angle is given, this angle is given. The third angle in the triangle can be, you can find the third angle in this triangle using sum of angle in a triangle. So when we now know this angle now, then we cannot use that angle with this side given. So that's not a pair. We cannot use to find this other pair that is given halfway, given this angle, looking for this side. So if you find this third angle here, we cannot apply sine rule for this triangle. So sine rule can still work with this triangle if you find this angle that is there. So that will not give us a pair. Do we understand that? Good. Now let's see some example under sine rule. Now we are given a triangle, given this angle as 48 degrees, given this angle as 35 degrees, given this side as 12 centimeter, which is the side facing this angle 48 degrees. So we have to look for this side labeled x. The question is, can we apply sine rule to solve this triangle? Looking for this side. I want you to understand. I want you to answer that question. Can we apply sine rule? The answer is yes. You can apply sine rule. Reason, a pair is given completely. This angle is given, and this side is given. So that means this is a pair. So the angle is given, and the side facing is also given. So a pair is given. So look at the side we are looking for. The angle facing that side is also given. So that means this other pair is given halfway. So we can apply sine rule here. Do you understand that? Then how do we formulate the sine rule we are going to use now? How do we formulate the sine rule? I told you we cannot use the three sine rule at the same time. We can only use two. And how do we formulate it? That will be the side this side that is facing this angle, this side which is 12 centimeter over the angle facing it, over the sine of the angle facing it. That will be 12 over sine 48 equals to x, which is the side we are looking for, over the sine of the angle facing it. I repeat, 12 over the sine of the angle facing it, which is sine 48, equals to x over sine of the angle facing it, which is 35. So if you look at it, so we are to look for value of x. So if you look at it, you are going to be having, this is the sine rule we have applied now. 12, which is the pair given to us completely, which is 12 over sine of 48 degrees, equals to x, which is the side we are looking for, over the sine of angle 35 degrees. Please, you cannot change this. Probably I should let you know that you cannot change this one. You cannot say this is 12 over sine 48. You now write equals to sine 35 over x. No, you cannot change it. The way this one looks, this one will look like this. It will be side over the sine of the angle equals to the side over sine of the angle. If you want to change it, you can change it to be sine 48 over 12 equals to sine 35 over x. You can do that one but that means the side over the angle equals to the side over the angle. I can have the angle Sine of the angle over the side equals to sine of the angle over the side. Anyone you want to use, that one is correct. But you cannot use 12 over sine of this equals to sine of this over x. No, you can't use that one. That you can't use that way. Do we understand that now? So from there now, our aim is to find x. What can we do? We can cross multiply. If you cross multiply, x will multiply sine 48. So we have x sine 48 equals to 12 will multiply sine 35. 12 times sine 35. From there, our aim is to find x. That we can divide both sides by sine 48. Divide both sides by sine 48. So if I divide this one by sine 48, we have x left. Then divide this one also by sine 48. So we have 12 times sine 35 over sine 48. If you press your calculator using your calculator for this, 12 times sine 35 press equals to, you give an answer divided by sine 48. That gives us 9.3 centimeter. So that will give us the value of our s to be 9.3 centimeter, approximately to one decimal place. Let's see another question. Let's say I have another triangle like this on the screen right now, and this angle is giving us 82 degrees, and this angle is giving us 25 degrees, and this side is giving us 15 centimeter. You have to look for this side, which is tag y. The question is, can we, okay, you have to look for the value of y. Can we apply sine rule to this to find the value of y? That's the question I'm asking the viewers. Can we apply sine rule to resolve this triangle to find this side? Currently, no. Why? This angle is given, the side facing is not given. This angle is given, the side facing is not given. This side is given, the angle facing is not given. So technically you cannot use sine rule currently because no pair is given completely. So this pair is not given completely, this pair is not given completely, then this pair is not given completely as well. But if you look at it critically, if you look at these triangles critically, two angles are given. So that means you can find this third angle here. We can find this third angle here using what? Sum of angle in a triangle. We know that sum of angle in a triangle should add up to what? 180 degrees. So this plus this, you now remove it from 180 should give us this angle here. So if you call this angle theta, then when we now do the value of this angle now, then with the side facing in, that will give us a pair now, given completely. Then we can now use sine rule now. Does that make any sense to you? So that means you can find this angle theta. So if you find theta here, theta will give us 180 minus 25 minus 82, and that will give us 73 degrees. The reason being that sum of angle in a triangle is equal to what? 180 degrees. So to get this third angle, we have 180 minus 82 minus 25. That will give us 73 degrees. So that means this angle theta here is 73 degrees. So that means we now have a pair complete now. This angle and the side facing it. So that's a pair. So it means we can now apply sine rule now, since we are looking for this side and the angle facing it is given. So if that is the case now, then we need to formulate the sine rule we are going to use. We need to formulate the sine rule we are going to use. We are using this pair that is given completely against this one that is given halfway. So how do we do that? That will be this side, which is 15, over the sine of the angle facing it, which is sine what? 73. Because theta here is 73, equals to the side you are looking for, which is y, over the sine of the angle facing this side, which is 82, sine 82. So we have been able to formulate the sine rule to resolve this triangle like this. Do we understand that? Good. What can we do here? We can cross multiply like as well. Y will multiply sine 73. We have y 73. So we have y sine 73 equals to 15 will multiply sine 82. We have 15 times sine 82. Then from there, what do? We divide both sides by sine 73. So that will give us y equals to 15 times sine 82 over sine 73. Punch your calculator, that will give us 15.5 centimeter, approximately to one decimal place, as the value of what? Y. So I hope you are enjoying and I hope you understand how we apply sine rule to solving this question. Let's see another question. You are given this triangle also, and they're giving this angle to be 65 degrees. The side facing it to be 10.6 centimeter. So we are given this side to be 7.5 centimeter. You have to look for this angle. So we can see this triangle as well. We are given this side, looking for this angle, the angle facing it. You have this side given, and we have the angle facing it. So can we apply sine rule here? The answer is yes, because we have a pair completely given. This side is given and the angle facing is given. So that means this is a pair completely given. And the second pair is given halfway. We are given the side, looking for the what, the angle. So we can use what, sine rule. So previous examples that we have solved, we have looked for side given the angle. In this case, we are giving the side looking for what, angle. So we can use sine rule. Can use formulate the sign we are going to use for this triangle. Please formulate the sine rule yourself. You are going to use to solve this triangle. Can you formulate it yourself? Please formulate before we. You can pause this video and formulate the sine rule before we now continue. So if you have formulated the sine rule, let's see whether you get it right. That means you'll be having 10.6 over sine of the angle facing, which will give us a sine 65, equals to 7.5 over sine theta. So we have to find the value of theta. So we'll be having 10.6, which is this side, over the sine of angle 65, which is the pair given completely, equals to 7.5 over sine theta. So what do? We cross multiply as well. We have 10.6 multiplying sine theta equals to 7.5 multiplying sine 65, like this. From there, our aim is to find theta. So what do? We divide both sides by 10.6, because theta is an angle, so it's a trigonometric ratio, so it's an angle. If you understand trigonometric ratio, you know what to do from here. But if you don't, please visit my video on trigonometric ratio so that you understand what you are going to do here. You can divide both sides by 10.6, so that will give us sine theta here equals to 7.5 sine 65 over 10.6. So from there, if you simplify this one with your calculator, you have 0.6413. Our aim is to find theta. That means theta will be equal to, you divide both sides by sine. So that we have theta equals to sine inverse. When sine gets here, it becomes sine inverse. Sine inverse of 0.6413. And if you press the calculator, sine inverse of 0.6413, sine inverse is, if you press the calculator, you have a shift sign that will give us sine inverse of this, and that will give us 39.9 degrees, because our angle, we are looking for theta, which is an angle. So theta is 39.9 degrees, approximately to 40 degrees as the value of our angle theta, still using sine rule. I hope you understand that. So let's see another question. In the question here, we have that in a triangle XYZ, so that means you have a triangle XYZ, angle Z is 51 degrees, angle Y is 67 degrees, and side YZ is 15.2 centimeter. We have to solve the triangle. So they want us to solve the whole triangle. That means you want us to find all the angles in the triangle, all the missing angle we have to get, and all the side that is missing they have to get as well. What do? The first thing is to sketch the diagram, or to sketch the triangle. So if I draw my triangle like this, am I right? Yes. So if I call this side, this point here, this angle here, if I call it X, so that means if I call this one Y, and I can call this one Z, so I have triangle X, Y, Z. So angle ZX is what, 51. This, I mean, angle here is 51. Angle Y is what, 67. This will be 67. Then side YZ is given to us. This side is given to us at 15.2 centimeter. So you put it there. So we have to resolve the triangle. That means we need to find this third angle, 1. Then we need to find this side, and we need to find this side. So we need to get this angle, so which is we have marked like this. Then we need to find this side, and we need to find this side as well. So that's how to resolve this triangle. So how do we do that? How do we get this third angle? I think that one is very simple. We are given these two angles, so sum of angle in a triangle should give us that angle. So angle Z is going to be 180 minus 51 degrees minus 67, which are these two angles given to us. That will give us 62 degrees. Reason sum of angle in a triangle is what? 180 degrees. So add these two together, remove it from 180, that will give us this angle. So you have been able to get this third angle. Now let's find one of the side, whether this side or this side, we don't know yet. But the question is, can we apply sine rule to find any of these two sides? Since all the three angles now are given completely, we now know this angle, we have this angle, we have this. Can we apply sine rule here? Yes, we can apply sine rule. Why? This angle is given and the side facing is given, so that means a pair is given completely like this. Is that correct? So we can now use that to find this side given the angle facing it, and we can also find this side given the angle. We now know the angle here as well. So let's see, what do we find for? We find xz, side xz. And how do you find sine xz? That will be we now use this pair given completely against this pair we are looking for. Against this pair we are looking for. So you have 15.2, which is the side, over sine of the angle, equals to the side we are looking for, which is side xz, over the sine of the angle facing, which is sine 67. Do we understand that? Then from there, what do? We can cross multiply. This side will multiply sine 51 equals to this side multiplying this as well. So we can divide both sides by sine 51 to get our side xz. So you have 15.2 times sine 67 over sine 51. If you simplify with your calculator, we have 18.0 centimeter as this side. So now that we know that xz is 18.0, we can also find, you have to look for this side as well, which is side xy. So we can also use sine rule as well. We can use this side against this pair we are looking for. For this side, we are looking for the angle facing it is given now, or we know the angle facing it, which is 62. So we can use this side we are looking for against this side given completely. Also this side now, so this pair now, we now have this pair completely, since we know this angle 67 and the side facing it we already got, which is 18.0. So I can use this pair against the one we are looking for, or I can still maintain this pair I have against the one you are looking for. Any one you do will still work. Are we there? So if you look at it, we have okay, we see maintain this pair given to us completely. 15.2 over sine 51 equals to the side we are looking for over the sine of the angle facing it, which is sine what? 62. This angle here is 62. From there we cross multiply. We have this times this equals to this times this. So from there, divide both sides by sine 51 to get our side xy. That gives us 17.3 centimeters. So we can see that we have resolved everything that is missing in this triangle using sine rule. So having understood the sine rule, let's talk briefly about cosine rule as well, and then let's know the condition that warrant us to use the cosine rule. And now let's see, this is a triangle as well. So also this triangle is not a right angle triangle. If I call this angle A, and I call that means the side facing it will be having a small letter a rather, just like the example I gave under sine rule. If this angle here is angle A, that means side facing will be have small letter a. So if this angle here is angle B, the side facing will carry small letter b. If the angle here is angle C, the side facing will carry small letter c. Then from there, what does cosine rule, what does it say, or what is it saying? Assuming I'm looking for this side which is small letter a, then the cosine rule say that the square of this side equals to the square of this plus the square of this minus 2 multiplied by this times this cos the angle facing the side I'm looking for. Let's assuming I'm looking for side A, so I'll have a squared equals to the sum of the square of the remaining two sides, which is b squared plus c squared, minus 2 multiplied by this and this, which is b times c, cos the angle of the angle facing the side I'm looking for, which is angle what? A. Even if I'm looking for angle A here as well, Assuming I'm looking for this angle A, that means I'll be giving this side A, the side facing it. So I will still use this cosine rule as well. A square equals to B square plus C square minus 2BC cos A. What if I'm looking for this side B? That means I'll be giving the angle facing it. Can you formulate the cosine rule for this to find this side B based on what you're having here? Can you formulate the cosine rule for if you are looking for side B? So that means you'll be having B square equals to the sum of the square of the remaining two sides that is given A square plus C square minus 2 then AC, that is A times C cos the angle facing the side you're looking for, which is angle what? B. You can also use this cosine rule to find angle B as well. Assuming I'm looking for side C, can you formulate the cosine rule for us as well? Assuming I'm looking for side C, which is small letter C. So that means you have C square equals to A square plus B squared minus 2AB cos the angle facing C is what? C, cos C. So you have a C square equals to A square plus B square minus 2AB cos C. So these are the three cosine rule for this triangle based on the angle and the side given to us. But I must tell you that you don't need to cram all this. Every triangle given to you to resolve, you are going to formulate cosine rule for that triangle. So if I'm given a question to solve and I'm sure that I'm going to use cosine rule instead of sine rule, then I should be able to formulate the cosine rules based on that triangle given to me. Just like when we are dealing with the cosine sine rule, at every question given to us, we are able to formulate sine rule to solve that particular question. Once we are determined that, or once we have confirmed that we are going to use sine rule to solve that question, we should be able to formulate sine rule for that question. Also, anytime you are given question and you are sure that you are going to use cosine rule, you should be able to formulate cosine you are going to solve that particular question. So if that is taken care of, what condition must be satisfied before I can use cosine rule? Before I can use cosine rule, I must be given two sides. Two sides must be given with an included angle. I must be given two sides with an included angle. I can be given side B and side C and side B with an included angle. That is the angle between this side and this side given to us is an included angle. So when I'm giving this side and I'm giving this side with an included angle, I can use what? Cosine rule. That means I'll be looking for the side facing this angle. If I'm giving this side, I'm giving this side with an included what? Angle. So that means I'll be finding what? C. I'm giving this side and this side with an included what? Angle. That means I can use it to find what? B. So to use cosine rule, I must be giving two sides with an what? An included what? Angle. Or if I'm not giving this two sides with an included angle, I must be giving three sides. If I'm giving these three sides, side A, B, C, I can still use cosine rule to find any of the angle of that triangle. Because all these things we are saying are not possible under sine rule, but they are possible under cosine rule, as you're going to see very soon. All right, let's see some tryout. I'm giving this triangle now, giving this side and this side, giving an angle, included angle between this side and this side, which is angle 45. We are looking for the side Y. Can I use sine rule in this case? Can I use sine rule to find this value of Y? Sine rule now, I'm not saying cosine rule. Can we use sine rule? I'm just asking you a question now. No, we cannot use sine rule because no pair is given completely in this triangle. So we cannot use sine rule. This angle is given, we don't know the side facing it. So this side is given, you don't know the angle facing it. This side is given, we don't know the angle facing it. So no pair is given completely. So we cannot use sine rule here. But can we use cosine rule? Yes, we can use cosine rule because we are given two sides with an included what? Angle, looking for the side facing the angle. So you can use cosine rule in this case. Another one. Let's see this triangle. Can we use sine rule in this case as well? We are given the three sides of the triangle, looking for this angle here, theta. Can we use sine rule? The answer is no. We cannot use sine rule as well because no pair is given completely. No pair is given completely in this case. This side is given, the angle facing is not given. This side is given, the angle facing is not given. This side is given, the angle facing is not given. So no pair is given completely as well. So we cannot use sine rule here for this triangle. But can we use cosine rule? Yes, we can use cosine rule because we are given three sides of the triangle. So we can use three sides to find one of the any of these three angles here in this triangle. So we can use cosine rule in this case, as we are going to be seeing very soon. Let's see another triangle. We are given this triangle to find the value of y. Can we use sine rule here for to find this side y? Can you use sine rule for this triangle? The answer is yes. We can use sine rule here because a pair is given completely. This angle is given. The side facing is given. So this is a pair given completely. Then this side is not given. We are looking for it, and the angle facing is what is given. So we can use sine rule here, but we cannot use cosine rule. We can use sine rule here, but we cannot use what cosine rule. So technically, some question. So technically, if you want to resolve some triangle that is not a right angle triangle, if sine rule does not work, cosine rule will work. And if cosine rule does not work, sine rule will work. So that's how you see it. In some question involving triangle that we are to resolve, which are not right angle, which are not a right angle triangle. If sine rule does not work based on the condition, then cosine rule will work. If cosine rule does not work, sine rule will work. I want you to see it that way. So let's see some example under cosine rule. We are given this triangle with this angle to be x, y, and z. So we are given this angle as 45 degrees. This side xz, this side xz is given 7 centimeter, and this side yz is given as 6 centimeter. You have to look for the value of side xy. This side. You have to look for this side. The question is, which of the principle are we going to use? Am I going to use sine rule or cosine rule? I'm asking the viewers now. Am I going to apply sine rule to find this side, or I'm going to use cosine rule? The answer is I'm going to use cosine rule. I cannot apply sine rule here because no pair is given completely to use sine rule. So we are going to apply cosine rule here. So because two sides are given with an what included angle. This side and this side is given with an included angle. So we can use that to find the side we are looking for. Do we understand that? So we are looking for side xy. Can you formulate the cosine rule we are going to use? Having understood that we are going to use cosine rule, can you formulate the cosine rule we are going to use? Yes. So we are looking for this side. That means we have a side xy squared equals to side xz squared plus side yz squared minus 2 into bracket side xz times side yz cos z. We are looking for side xy. Side xy squared equals to side xz squared plus side yz squared minus 2 into bracket side xz times side yz cos z. So most time you don't need to write this. When as time goes on, we are going to be skipping this step. Based on the parameter given to us, we can slot in our answer straight away if you understand the cosine rule. So we are looking for this side xy. So we have side sy squared equals to this, formulating our cosine rule for this question. So if you substitute our values here, we have sy squared equals to xz is 7, we have 7 squared plus 6 squared minus 2 into 7 times 6. Xz is 6, xz is 7, then yz is 6 cos z, cos of this angle here is 45, so we have cos 45. From there, simplify further. 7 squared is 49, 6 squared is 36. 2 times 7 times 6 give us 84 cos 45. From there, this plus 3 give us 85 minus 84 cos 45. From there, your calculator will give you answer for this. You have 85 minus 84 cos 45. Press it like this. It will give us 25.60303. Our aim is to find side xy. So how do we remove this square? We need to find the square root of both sides. So side xy equals the square root of this. That gives us 5.1 centimeter, approximately to 1 decimal place. So that means side xy is 5.1 centimeter. So you can see the application of cosine rule to solving this side of the triangle, since we know that sine rule will not work. Let's see another example. I'm giving this triangle on the screen right now, and what can we see? We are given three sides of the triangle. We are looking for this angle, and the angle is tag theta. The question is, which of the principle can I apply? Can I apply sine rule, or can I apply cosine rule? The question is, we cannot apply sine rule because no pair is given completely if you look at it critically, but we can apply cosine rule because three sides is given. So we can apply cosine rule here to find this angle theta. Then how do we formulate the cosine rule for this question now? Our aim is to look for this angle. That means the side facing the angle, that will be square of it. So we have 5 squared equals to 6 square plus 4 square minus 2 times 6 times 4 cos theta. The angle we are looking for is theta, so the side facing it, we have 5 squared. So okay, if you remember the cosine rule, I just give you to remember the cosine rule to the general cosine rule. But even without this, if you understand what cosine rule is saying, our aim is to we are looking for this angle, so which is theta. Then what do we have? The side facing it, that way you are going to write first 5 squared. We have 5 squared equals to 6 squared plus 4 squared minus 2 into bracket 6 times 4 cos theta, which is what you are looking for. Do you understand that? So even if if I have this angle given to me, I'm looking for this side as well. So I'll see have this side squared equals to 6 squared plus 4 squared minus 2 into 6 times 4 cos the angle given to us. So if you simplify this further, 25 equals to 36 plus 16. This time, this give us 48 cos theta. From there, 36 plus 16 give us 52. From there, you can collect like times. 52 can come to this side. You have 25 minus 52 equals to minus 48 cos theta. This minus z will give us a minus 27 equals to minus 48 cos theta. Minus can take care of minus. Then our aim is to find theta. We can divide both sides by 48. So if you divide both sides by 48 here, divide both sides by 48, we have cos theta equals to 27 divided by 48, and that should give us 0.5625. Then to find our theta is to find cos inverse of this. Theta will be cos inverse of 0.5625, and that should give us 55.8 degrees approximately. So that means this angle here is given to us as it's going to be 55.8 degrees. Now that we know this angle, assuming that the question asks us to find another angle, let's say the question asks us to find this angle here now. I'm just saying now. Now we know this angle, and the question asks us to find this angle again. Can we now apply sine rule? Yes, we can apply sine rule because we now have a pair complete now. This angle is now given at 55.8, so that will give us a pair. So if you are looking for this angle now, you can now apply sine rule. That will be this pair against this pair we are looking for. Do we understand that? Now let's see another question. From triangle XYZ, angle Y is equal to 128 degrees. Side YZ is 7.2 centimeter. Side YZ is 4.5 centimeter. We have to find Y. We have to find Y. So if you draw this triangle very well, you are supposed to have something like this. Why are we having something like this? Because this angle here given to us, angle Y is an obtuse angle. It's greater than is not an acute angle. So we are not supposed to have all the angles of that triangle to be acute. Since this angle here is given to us as a 120, it's more than 90 degrees. So it's an obtuse angle. So obtuse angle should be more than 90. So you have to draw your line like this, and the line should be bent like this. It's not supposed to be like this. It's supposed to be bent like this. So that means this angle here is more than it's more than 90 degrees. It's 128 degrees. So I can label this triangle X. Then this will have a Y. Then this will be Z based on the triangle XYZ. Then this angle here will not be what? 128 degrees. The angle here will be 128 degrees, which is an obtuse angle. Then SY, where is XY? SY will be 7.2 centimeter. Then YZ is 4.5 centimeter. Question has also find Y. You can see that this question is given to us. They didn't draw the diagram for us. We are the one drawing the diagram. So some question will come in a way that you only be given the question, no diagram will be given to you. So you should be able to sketch the diagram yourself. So like this case now, we have to look for Y, small letter Y. Where will Y be? Will Y be here, or here? Y will be here because Y is this small letter Y is the side facing capital letter what? Angle, capital letter Y. So this angle here is capital letter Y. That means the side facing it should be a small letter what? Y. So that means this side should be what? A small letter Y. Do we understand that? Then have you understood that? The question is, what principle can we use to find this side, which is tag Y? Is it sine rule or cosine rule? The answer is we can only use cosine rule, not sine rule. And you should know the reason why we cannot use sine rule based on what you have been saying since. So if you want to use cosine rule, what do we have? We have the square of the side we are looking for, which is y squared, equals to this square plus this squared minus 2 into this times this. You need to remove your square here before you don't put square here in the bracket here. So we have to into by 7.2 times 4.5 cos the angle facing, which is 128. If you square this, 51.84, square this, 20.25, then multiply this out 2 times 7.2 times 7.2 times 7.2 times 4.5, that gives us 64.8 cos 128. This plus this will give us 72.09 minus 64.8 cos 128. The calculator will do the rest for you. This minus this cos 128. Majority of the students will make mistake. Some of them will go and do 72.09 minus 64.8. No, that's not what you are going to do. This cos 128 is multiplying 64.8. So don't separate them. Press it like this. This minus this, then cos 128 is to give you 111.492334. Our aim is to find y, so you need to get rid of the square. So how do we do that? You find the square root of both sides. So y will be equal to square root of this, and that gives us 10.6 centimeter. So that means this side is going to be 10.6 centimeter. So assuming that the question asks us to find this angle x or angle z, that means you can now apply sine rule because we now have a pair complete now. We now have this side and we have this angle, so that's a pair complete. So we have this side now. We can find this angle with this pair or this one as well. But we are not asked to do that. We are only asked to find y. Alright, let's see another question. You are told that a triangle ABC has side A equals to 9.0 centimeter, B 7.5 centimeter, C 6.5 centimeter. You have to determine its three angles. So we are given the three sides of a triangle to find the three angles of that triangle. So the first thing you need to do is to sketch the triangle first. So if let's say this is the triangle, so I need to label it A, B, then C, based on what is given to us. So don't forget that all these values given to us are side. So if this is A, then that means the side facing it should carry small letter A, which is this angle here is angle A. That means the side facing should be small letter A. That will give 9.0 centimeter. So that means this side is for small letter A. This is angle B. That means the side facing it should be carry small letter B. So that means you have 7.5 here, and this is angle C. Then the side facing should carry the small letter C, which is 6.5. So you have 6.5 here, and we have 7.5 centimeter here. So you have to determine the angle is three angle. So let's assume we want to find this angle first. If you find this angle first, how do we do that? Can we apply cosine sine rule? No, because no pair is given completely, but you can apply what sine rule. So let's find this angle first by using cosine what rule. Pause this video. I want you to formulate the cosine rule we are going to use to find this angle. So if you have done that, let's confirm. So you are supposed to have, if you want to formulate the cosine rule, you are supposed to have 9.0 squared equals to, because that's the side facing this angle you are looking for, 9.0 square equals to 7.5 square plus 6.5 squared minus 2 multiplied by this and this cos A, which is cos of the angle you are looking for. So you have a 9 square equals to 7.5 square plus 6.5 square minus 2 into 7.5 times 6.5 cos A, cos of the angle you are looking for. 9 square is 81, this square is 98.5 plus 6.5 square is 97. Okay, sorry, you have done everything straight. This plus this, if you do 7.5 square plus 6.5 square, that gives us 98.5 square, 98.5 rather. Then this times 2 times 75 times 6.5, that gives us minus 97.5 cos A. Then from there we can collect like terms. We move this one to this side. We move minus 97.5 cos A to this side. You have a it become plus 97.5 cos A. Then this one comes here. You have a 98.5 minus 81, and that should give us a 17.5. So if you remove this one from this one, that gives us 17.5. So our aim is to find A. So you can divide both sides by 97.5 to get cos A here equals to 17.5 divided by 97.5. So this divided by this will give us 0.1795. To get A, you need to get the cos inverse of this. That should give us 79.7 degrees. So that means this angle here is 79.7 degrees. Now that we have this angle given now, so to find let's say you want to find angle B now, then we can now apply sine rule to find angle B. You don't need to apply cosine rule again. Although if you want to apply cosine rule as well, you can apply cosine rule to find angle B as well. To follow this principle, you have a 7 square, which is this side facing this angle, equals to this plus this square plus this square minus 2 into this times this cos B. You can apply that, but that will be a long process. Since we have a pair complete now, this angle is now given, we now have this angle to be 79.7, which is this angle A. So we have a pair. Now we can now use that to find this other pair, given the side, looking for the angle. So we can now apply sine rule here now. So how do we do that? That will be this side 9 over sine of the angle facing, which is sine 97.7, over, we are looking for this angle, the side facing is 7.5 over sine of angle what B, cross multiply. Now 9 times sine B equals to 7.5 times sine 79.7, divide both sides by 9. You have sine B equals to 7.5 sine 79.7 over 9. Use your calculator here, you have a 0.8199. Then to find angle B, you need to find the cosine inverse of this. That gives us 55 degrees. So that means this angle here is 55 degrees. Then you have to look for the third angle. You can use some of the angle in a triangle. To find angle C, we have this angle to be 79.7. You have this angle here to be 55. Add this and this together, remove it from 180. That should give us this angle to be 45.3 degrees. So you can see how we got the three angles now by applying both cosine rule and sine rule. Now, another question that could come your way in WAEC or NECO is that you could be given a question that in a triangle ABC, given the side of the side of the triangle, given the side AB to be 4 meters, BC to be 6 meters, and AC to be 8 meters, find the largest angle of the triangle. Now, in this case, they don't want you to find all the angles. They want you to find the largest angle. Another question could be find the smallest angle of the triangle. So that's another question that could come your way in WAEC or NECO exam. So you are given a triangle ABC. So I can draw the triangle. Say this is side AB. Call it 4 meters. Draw another line. Call it BC. Then call this one BC is 6 meters. Then join this together. We have AC. And that is 8 meters as well. So from this triangle now, we have to find the largest angle of the triangle. The question is, how do we know the largest angle? Having scaled the triangle to be like this, How do we know the largest angle of the triangle? Hmm. Or if person asks me to find the smallest angle, how do I know the smallest angle of this triangle? Now, let's go back to this largest angle. The largest angle of the triangle is the angle that is facing the longest side of the triangle. That is, the angle that is facing the longest side will be the largest angle of the triangle. Where is the longest side of the triangle? This is the longest side, 8 meters. So the angle that is facing it, where is the angle facing it? This is the angle facing it. Angle B is the one facing it. So that means angle B should be the largest of the triangle. What about if the question asks you to find the smallest angle of this triangle as well? Given this question again to find the smallest angle, which angle will be the smallest angle? Smallest angle should be the angle that is facing the smallest side. Sorry, the shortest side rather. This I said smallest side. The shortest side. The angle that is facing the shortest side is the smallest angle. So that should be angle C because the shortest side here is 4 meters. This side AB. So the angle facing which is angle B should be the smallest angle. So you are not looking. So in case you are giving that as well, you should be able to deduce the shortest, the smallest angle and the largest angle. So the largest angle will face the longest side, and the smallest angle will face the shortest side. Do you understand now? So we are looking for angle B in this question now. Now, you have known that you're looking for angle B in this question. Which principle can we use to find it? Can we apply Pythagoras theorem? Can we apply trigonometric ratio? Can we apply sine rule or cosine rule? We cannot apply Pythagoras theorem, cannot apply trigonometric ratio because this is not a right angle triangle. Now, between sine rule and cosine rule, which one will you apply? We cannot apply sine rule because no pair is given completely. This angle is not given, this angle is not given, this angle is not given as well. So, but three sides are given, so we can apply cosine rule. So I want you to formulate the cosine we are going to use for this triangle. Formulate the cosine we are going to use since we are looking for this angle. So pause this video and formulate the cosine rule yourself. So we should have AC squared equals to BC squared plus AB squared minus 2 into BC times AB cos B. So then if you want to substitute your answer, that means you'll be having 8 squared. So I've already explained how we get the longest side, the largest angle rather. How we get the largest angle to be B. I already explained that. So if you substitute your answer to the cosine rule, we have 8 squared equals to 6 squared plus 4 squared minus 2 into 6 times 4 cos angle B. 8 squared is 64 equals to 36 plus 16. 2 times 6 times 4 give us 48 cos B. 36 plus 16 will give us 52. Excuse me, minus 48 cos B. Take the like time as well. I can what can we do? And take 52 to this side, collect like times. So we have a 64 minus 52 equals to minus 48 cos B. And don't forget that there's a minus here, that's why we have this one to be minus. So you should know how to collect like times by now. 64 minus 52 give us 12 equals to minus 48 cos B. Then from there, you can divide both sides by minus 48. So that will you'll be left with a cos B here. So you have cos B equals to 12 divided by minus 48. That gives us minus 12 over 48. And that gives us a minus 0.25. To find our B, that means you need to get our cos inverse of minus 0.25. And that should give us a 104.5 degrees. So, and you can see that this angle here is an obtuse angle. So which befit this diagram. So if you have drawn your own diagram like this, having gotten this angle like this, so you need to erase the diagram and you draw it like this if it is Y question. If not, your answer will contradict your diagram. So if you have drawn the diagram and all the angles of the triangle are acute, so when after you might have gotten your answer like this, it's possible you can get your answer like this, then you need to erase the diagram and draw it like this because the angle you have gotten here is an obtuse angle, not an acute angle. So it should look like this. So I believe you have you understand the sine rule and cosine rule based on the way we have explained so far. So if you understand this, I want you to try attempt these two questions you have on the screen right now. So you have to find the value of Q, you have to find angle R, angle Q in this diagram, given this side and this side and this angle. So you should be able to tell us which principle can you use to solve this now based on what you have done, whether sine rule or cosine rule. Also this one as well, we have to find angle A and angle C. So given this angle, the side facing it, this side, so we should be able to tell us the principle you can use to find this as well, be whether sine rule or cosine rule. So up next, we are going to be talking about bearing and distance, and I want to tell you, you cannot miss the video. It's going to be an awesome video and wonderful video. We are going to be solving lots and lots of past questions on bearing and distance, and you are going to understand this because I'm going to explain it in detail for you. But before you can understand bearing and distance, please you must understand sine rule and cosine rule very well, and trigonometric ratio. So visit my video on trigonometric ratio if you don't understand trigonometry very well. And thank you for watching. And please, before you go, if you are yet to subscribe to the channel, don't forget to subscribe right now. Click on the notification button so that you'll be notified whenever we post information on this platform. Thank you for watching, and don't forget to subscribe. Don't forget to share the video with students out there. And as you do so, may the good Lord bless you. I will see you in the next video. Bye.